On number 10, we want to find the amplitude, okay? From the top to the bottom, we see that the scale's going by 1, so that's 1, 2, 3, and half of 3 is 1.5. So we're going to say our amplitude is 1.5. Wait, 1, 2, 3, 4. You're right. I'm sorry. Our amplitude is 2. Because we're counting by 1, 2, 3, 4. Remember, you can also find the amplitude by starting off at 1 and subtracting -3 and then dividing by 2. That would give us a plus a positive, which is 4 divided by 2. So this is another way to check on your test if you would like to make sure that your amplitude is 2. Now, on number 10, the amplitude is again from the top to the bottom and half of that. So that's 1, number 11, thank you, 1, 2, 3, and then half of that would be what? 1.5. Okay, now we also need to talk about the period. It also asks us to find the period of each periodic function. The period is the time that it takes the distance that it takes to finish one complete cycle, okay? So if we started here, we would go around until we have completed one full cycle, okay? And that distance would be what? What is our period on number 7? Yes, sir. Oh, thank you very much. All right, what is that? Who can tell me? Card, please. Holla? I understand. I'm saying, Holla, could you please tell me? Holla, could you please tell me what the period is in number 7? 7. The period. The period. 4? Okay. So the period is the time that it takes us to complete one full cycle. So that would be from 0 to 2. So the period in number 7 is 2. Do you see that?
Yes, because it's 2 times. Yeah.
If you have a question, please raise your hand. Yes, ma'am. The period is the time it takes to complete one cycle. I drew the one full cycle on there. So from 0 to 2 is the amount of time it took, the distance it took to complete one full cycle. Right. Okay. On number 8, you can start wherever you want to. I'm just going to start here. So we go down and then come back up. Is that one full cycle? Yes. So we go down and come back up. So then we start at 3, we end at 6, so the period is 3. Very good. On number 9, we can start here at 2, right? And then we can end back up here at 4. I'm sorry, that would be 2, 2.5, so 3, 3.5, 4. Right. So what is our period? 2. Are there any questions? Okay, if you look at number 13, on number 13, could you draw a card, please? David, on number 13, what is the amplitude? 2.5? Okay, how did you get 2.5? Okay, and then from the top to the bottom, there's a difference of 5, and then you took half of that. Did everybody else get an amplitude of 2.5? Okay, and David, what about the period? 4? Is that what you guys got? We start here, we go down, right? Then we go up, and before we start over, so from here, that's 1, 2, 3, 4. So our period is 4. All right, are there any questions?
Can you do the amplitude one last time? See, I'm not so confused how you got 2.5.
Right. Okay, so do you see the highest the graph goes is 2? And the lowest it goes is -3. So 2 minus -3 divided by 2. that would give you 5/2, which is
I
2.5.
counted the rest of it. I just got to divide it by half.
Okay. Yeah. Okay. So number 14. So if we started here, we'd go little one, and then we go up and then back down, right? So we'd start here, -2, little one, up and back down. Card, please. Hiram. Skip Hiram. He hasn't been here. Kevion, what is the amplitude? One and a half. Are you sure about that? I'm sorry? Yes, 1.5. Okay. And what about the period? 5. Is that what everybody else got? All right. Any questions? Okay. Yes, sir.
So how's it 1.5 then?
Okay, because the top is 0 and the bottom it goes down to -3. So 3 is the difference between the top and the bottom, and half of that's 1.5. Okay.
Okay.
All right. So I'm gonna let you guys finish the rest of these on your own time. We've got to get to sine graphs right now.
Sine graph.
Yes. Okay. Today we're going to start by graphing just this regular function, which is y is equal to the sine of theta, okay? Where the y would obviously represent our y coordinates, and theta is going to represent our x coordinates, where theta is an angle, okay? So let's talk about some things we know. We know that we're going to start here at 0, 0, or y is equal to the sine. For all the graphs we're going to look at, we're going to look, we're just going to be seeing how many cycles there are from 0 to 2 pi. So we know that the very end is going to be 2 pi. Okay? Now if we cut that in half, what is that going to give us? Very good. And if we cut that in half, that would give us pi over 2, right? Let me make this a little bit smaller. Now, what if I cut this one in half? 3/2, or 3 pi over 2? Okay, so we're going to start here at 0, and this is just 1 and -1. If we start here at 0, what is the sine of 0? I want y'all to think about our unit circle. Right? What is the sine of 0? What are the coordinates here? 1, 0. So at 0 degrees, what is the sine? 0. So when x is 0, y is 0. Do you see that? Okay, so sine of 0, this is y equals 0. The next thing we want to find is the sine of pi halves, right? So this is y is equal to the sine of pi halves. Draw a card, please. Daniel, what are the coordinates right here at pi halves? 0, 1, right? So what's the sine of pi halves? Daniel? What's the sine of pi halves? 1, right? So then that would mean y equals 1 here. So at pi halves, the y coordinate is 1. Do you guys see that? Do you see this, yes? Did you say what's happening?
Yeah.
Okay. We're using the unit circle, and we're just graphing the coordinates from that, okay? So the sine, remember this is y is equal to the sine of theta. Well, when theta is 0, right?
Yeah.
When theta is 0, when this is 0 degrees, then guess what? The sine is 0. So that's 0, 0. Okay? Now, remember that this is pi halves here. Our radians are pi halves here, right? So when x is pi halves, so the sine of pi halves is equal to 1. So when x is pi halves, the y value is 1. Do you see that? Are you sure? Now, Sam, what happens? What is the sine of pi, Sam? At pi, which is here, right? This is pi.
Yeah.
What are the coordinates?
That's like -1, 0.
Good. So what's the sine there? What's the sine of pi?
0.
The sine, remember exact values. We've been doing exact values, right? So the sine of pi is 0. Okay? Now, the next thing we want to do is, Sam, what is the sine of 3 pi over 2?
Oh yeah, 0, -1.
Good. So when the sine of 3 pi over 2 is -1. Now, what is the sine of 2 pi, Sam?
1, 0.
Right? So the sine would be 0. Okay? We create this periodic function. Okay? It's not, I didn't sketch it the most beautiful, but do you see how this is a periodic function? Okay, and then this periodic function, y equals the sine of theta, it completes one complete cycle in between 0 and 2 pi. Okay, so we don't have to go through this whole thing. There are lots of different ways that we can, or lots of little tools I've put here to help us graph these pretty easily, okay? The standard form for a sine function is y is equal to a times the sine of b theta, okay? A, or the absolute value of a, is going to be the amplitude, which we know what the amplitude is, right? And b is the number of cycles from 0 to 2 pi. So it'll tell us how many times we're going to repeat our cycles. And the period, which remember tells us how long each cycle is just going to be 2 pi divided by whatever our b is. So remember, our b is the number in front of theta here. The number of values to label on the x-axis is 4 times b, which we'll talk about what that means in just a moment. And the scale, which means how much we're going by, what we're going to label each one as they increase, is going to be our period divided by 4. So let's start off by just identifying a and b. On number 1, a is 2 and b is 1. Okay? On number 2, draw a card, please. Allie, on number 2, what is a? Remember, y is equal to a times the sine of b theta. So what is a? Or our amplitude? It's in this form, y, so that's 2. Do you know why it's 2?
Yes, I know.
Why? Right, and then b is 2, right? That b is not our period, though. I just want us to identify a and b. On number 4, Tiffany, what is a? What? Good, and what is b? It's whatever's in front of theta, which is 1. Good, good. Okay, so do we get this? We're good with a and b now. All right, let's go back to number 1. So in number 1, our amplitude is what? Draw a card, please. Aya, what's our amplitude on number 1? Our amplitude is 2, good. And that just means that this is going to be 2, and this is going to be -2. Okay, and then what is our period going to be, Aya? Our period is just, how did you get that, Aya? Right, our period is 2 pi divided by b. Do you see that? On the top right, it says the period is 2 pi divided by b. I'll write it right here where we can see it. Period is equal to 2 pi divided by b. And in this case, what is b, Aya? 1. Good. So what is our period? Just 2 pi, right? Which means this is going to be pretty easy for us. All right, to determine how many we're going to break this up into, or I guess how I put it here is the number of values to label on the x-axis is just 4 times b. So what is b? 1. So it's just 4. So we'll just have 1, 2, 3, 4, right? All right. The number of values to label on your x-axis. So the number, we want to break this up. And the number that we break it up into, the number of little hash marks that we need is just 4 times b, which is our number of cycles. Because we're going to divide each cycle into 4 parts, right? Do you see this? 1, 2, 3, 4. But sometimes we'll have more than one cycle, which we don't know yet, but we're still learning, okay? So just trust me with this until we get some more examples. Would that be okay? So we're going to break it up into 4 cycles. Now, to determine how much each of these go by, all we have to do is take our period and divide it by 4, right? So what's our period? 2 pi. So what's 2 pi divided by 4? Pi over 2. So that means that this is 1 pi over 2. This one is going to be 2 pi over 2, which you know is just pi. This is going to be 3 pi over 2. And this is 4 pi over 2, which is just 2 pi. Okay? Again, we're going to start at 0, 0, up 1, middle, down 1, middle. Okay? Something like that. 1 full cycle. It's not always going to be 1 full cycle, and that we'll see that in example number 2. Are there any questions about example number 1? All right, so on number 2, draw a card, please. Alvin, on number 2, what is the amplitude?
2.
2, very good. And what is the period, Alvin? Remember? 2 pi divided by b.
Divided by b.
Uh-huh. So our period is 2 pi divided by what, Alvin?
2 pi divided by 2.
Good. Alexia, what is our period? Okay, let's look right here. Our period is equal to 2 pi divided by b, right? What is b, Alexia? B is 2 because, remember, it's y equals a times the sine of b theta, and b is the number in front of theta, right here. It's 2. Do you see that? So the period is equal to 2 pi divided by 2. So what's our period, Alexia? Period is pi. Very good. Now, the next kind of step we have to take in graphing these is we know that this very end one is going to be 2 pi, right? We don't know how many little hash marks we need to make, how we need to divide this axis in 2, okay? In order for us to determine that, it's just equal to the number of values, or the number of values to label on the x-axis is just equal to 4 times b, okay? Where b is our cycle, because each cycle we break up into 4 parts. So we look and we say, what is b here? What is b? 2. So what's 4 times 2? 8. So we're just breaking this up into 8. 1, 2, 3, 4, 5, 6, 7, 8. Do you see that? I know that the reason I have this on here is I knew you were going to want to know how many you break it up into before you started graphing, because you're going to want them to be even, right? Now, what do I know the last one is going to be? Always, for what we're doing, since it says 0 to 2 pi. It's going to be 2 pi, right? And what is this number here? Because of the amplitude, and this is? Very good. Okay, so in order for us to determine what we're going to start off with here, we just want to take our period and divide it by 4. What's our period? Pi. And what's pi divided by 4? Pi fourths, right? Another way you guys can look at this is each one of these hash marks are the same, right? So from 0 to here is the same, from here to here is the same, correct? If the whole thing, the whole length is 2 pi, then we're just taking that 2 pi and we're dividing it up into 8 equal pieces. So guess what 2 pi divided by 8 is? It's also pi over 4. Good. So there's just more than one way you can look at this, okay?
Yeah.
So that means we're going to start here with 1 pi over 4, right?
Yeah.
Okay.
And that would be 2 pi over.
Very good, Alvin. 2 pi over 4. And what's the next one? 3 pi over 4?
Yeah.
And the next one?
4 pi over 4.
Good.
Is 5.
And this would be?
5 pi over
Very good.
6 pi over 3.
Good. And this one?
7 pi over 3.
Very good. Any questions?
Can I just simplify?
Yes, please simplify it if you'd like. The reason I didn't, I just wanted those of you who aren't getting this to see that, okay? You need to get your head up and take notes now. Are there any questions? Okay, so let's start graphing. We start here. Yes, yes, go. You don't have to simplify them, but you do need to write them. Does that make sense? As long as you understand kind of what we're doing and what this is about, okay? So we're going to go up, middle, down, middle. Okay, I'm going to turn this so I can graph it. All right, do you see what happened here? All right, our cycles just became a little bit shorter. Do you see? But it's still the same thing. Any questions? How did I what? Like 2 pi divided by 8? Is that what you're asking? Well, can I show? I'm going to have to move it for a second to show you. Remember, this is one full cycle, and we divide it up into 8 parts. Into 4 parts. 1, 2, 3, 4. Each cycle we're going to divide into 4 parts, right? Well, here, our B is 2. We have 2 cycles, which means we've got to divide it up into 8 parts. 4 parts for the first cycle, 4 parts for the second cycle. Does that make sense? If B were 3, we divide it up into 12 parts. Do you see that? You do see that? Okay. All right. Are there any questions here? Okay, let's go on to number 3 is just going to be like number 2, right? We're going to divide them up into those same amount of parts. What I would really like us to do is, I'm afraid we're going to run out of time. I'd like to do number 5 because this one's kind of ugly. All right? So on number 5, draw a card, please. Murphy, what is the amplitude?
The amplitude is -2.
Close. Remember the amplitude, it's the absolute value of A.
So it's
Just 2, right? Because remember amplitude is like a distance, so it can't really be negative. Does that make sense? So this is 2. Okay. Now, what is the period? Oh, draw a card, please. Tiffany, what's the period going to be? Do you remember how to find that? Period is 2 pi over B. Good. And what is B in this situation? It is 4. So our periods are going to be pi halves. Okay? Now, I just want you guys to kind of soak this in for a second because I want you to like really understand what we're talking about. If our period is pi over 2, what does that mean? Like, what does that mean? Anybody can tell me anything they know about that. Actually more. Do you remember what a period means? Like, what does that mean? Can anybody remember? It's not how many. Anybody? How long they are, right? So how long are our periods in example number 5? They are short, right? Which is bad news for us because that's a lot of stuff to do. But they're short, so we're going to have lots of little bitty guys. Do you see what I'm saying? If you look in our example, from 0 to 2 pi, that is 1 cycle, right? But guess what? We are making that cycle. We're making just right here this to be 1 cycle. So we got a lot of little graphing to do, don't we? Okay? So we need to decide how many portions we need to break this up into. Patricia, how many 4 times 4. It's 4 times B. And what is B? 4. Okay? So 16. Okay, you guys ready? All right, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. Ooh, I could have made those longer, couldn't I? Oh, well.
So you got 6.
Right. And we got 16. So if we want to break up, if you have 2 pies and you want to break them up into 16 equal pieces, how do you do that? You would take 2 pi and divide it by 16. Right. What does that give you? Pi over 8, okay? Think about there are only 16 people in here. We have 2 pies, right? We can give everybody how much? Or just maybe 1/8 of a pi, right?
Yeah.
Does that make sense? at 16 because we know that we're breaking these up into, remember up here, the number of values to label on the x-axis is equal to 4 times b. So we go back down here, and b is 4. So 4 times 4 is 16.
Okay.
Do you see now?
Yeah.
Are you sure?
Yeah, I just need to get all this stuff.
No, you're fine. Of course, we're just on the third example. It's okay. And what we're doing tomorrow, we're graphing cosine, but it's almost exactly the same as sine. There's just a few little differences, but it's pretty much tomorrow we're doing the same thing, so don't panic, okay?
Okay.
All right, so 2 pi divided by how many equal parts do we need? 16, and that gives us pi over 8, which means we're increasing by pi over 8 each time. So this is 1 pi over 8, right? Guess what this one is? You'll have more room on your test, okay? 1, 2, 3, 4, 5, 6, 7. I'm just writing pi here, right? Because that's 8 pi over 8. You don't have to, but you need to know that they're equivalent. Yes, yes, ma'am.
How did you get 2 pi over 16?
Because we saw that we broke this up into 16, and we wanted 16 equal parts, so we wanted to say if we have 2 pi, we broke them up into 16 equal parts, how long is each part? Do you see? 1 pi over, wait, okay, that's 9, 10, 11. So we get 15 pi over 8, and we'd end up with 16 pi over 8, which is 2 pi, right? If I ended up with 14 pi over 8, would I know that I made a mistake somewhere? Yes, because we needed to end up with 16 pi over 8. Okay, so you ready for this next part? Before we finish, guess what? What's different about this problem, other than we had to do 1,000 little marks? Negative. So guess what that means? It-
Pull it down.
Is going down, right? So instead of us, remember on all these, we would start at 0, 0, and we go up, right? Guess what we're going to do here?
We're going to go down.
0, 0, we're going to go down.
It's kind of like an inverse of what we did.
Up here. So I'm trying to get this a little bit more accurate. It's hard to do when these points are so small, huh? Okay. All right, so it looks a little weird because I'm bad at graphing, but it should look symmetric, okay? How do y'all feel about that? Okay? Are we okay with this? All right, let me tell you what your homework is. You still have 2 minutes, so you might be able to finish at least one of these problems. Your homework is going to be number 4 and 7. Number 4 and 7.